Hello, my name is Solomon Andrews. I am a third-year mechanical engineer from Florida A&M University. And this summer, I was given an opportunity to work at the NASA Marshall Space Flight Center. The project I was working on is called Green Propellant Technology Developments for SmallSat Propulsion Systems. And the propulsion system is called a GPDM FlatSat version 2. GPDM stands for Green Propellant Demonstration Module. So, quick overview of what's going on is here in the propulsion laboratory, we are developing a second generation FlatSat propulsion system for a lunar flashlight. And basically it will simulate the future flight missions of it. To get background on this lunar flashlight, NASA wants to build communities on the moon. NASA wants to build livable buildings on the moon. And in order to do this, you're going to need natural resources. And the one natural resource that you need is probably going to be water. And instead of sending water to and from the moon, the best way to do this is through a lunar flashlight. And what it will do is basically pinpoint and locate ice deposits on the dark sides of the moon so that we can go and actually get those ice deposits and use them for consumption. It is no bigger than a briefcase, and it was sent to us by NASA's Jet Propulsion Laboratory. So our objective, build a FlatSat propulsion system capable of getting NASA's JPL mission into lunar orbit and maintain orbit for the duration of its operation. And if you don't know, a FlatSat propulsion system is basically an open propulsion system, meaning that it's not connected to the lunar flashlight, it's a propulsion system by itself. And this propulsion system will consist of 4 electrosprays and one 100 millinewton blowdown thruster, and a flight controller board, the CPRS, which is compact regulating system, and then of course, the propellant. Propellant is Accent, Advanced Spacecraft Energetic Non-Toxic. Accent is a green monopropellant that we are using instead of the common fuels like hydrogen. And it is very much safer, and it basically will increase performance of our propulsion system, and it's very, very accessible and easy to get your hands on. And what we'll be running it in is 100 millinewton blowdown thruster and the electrospray thrusters. And the 100 millinewton blowdown thruster, or 1 Newton blowdown thruster, is basically your average, thruster. It's like a normal, it runs until it's shut off, basically, until it has no more fuel left to go. Now, the electrosprays is more of it's not consistent like the blowdown thruster. The electrospray is basically going to be, it has a little tank inside of it, and it's going to fill up, and then we're going to shut off the valve, or basically turn it off, and basically just stop the flow of the propellant to the electrospray. And what it will do basically is every time on command, we'll basically spray it whenever we need to until it's empty, and then we'll fill it up again. So how do we build this propulsion system? How do we do this? Well, in order to do this, you're going to need to know a lot about tube manufacturing, and that's welding, tube bending, and knowing which fittings you want to use and what situation you want to use them in. The 2 main fittings that I want to discuss is the VCR fittings and the AN fittings. The VCR fittings it's what we use on the inside of the vacuum chamber. It's more reliable, it has a tighter seal, but the thing about them is you have to weld them every time you use them. So that's why we use them on the inside, because it's more reliable than the AN fitting. The AN fitting is a cheaper solution, it's quicker to assemble, it's just a flare, meaning that we use a machine to flare the tubing, and basically we'll just connect them together. And when we connect them together, we connect them based on a plumbing diagram that we have, like this one in the left. We have a plumbing diagram that we make and that we follow along, that we basically build the actual FlatSat based off of. And after it's completed, we'll be ready for testing. And when we run testing, our testing will be hot fire testing. And what we'll do is basically we'll test the thrusters individually, and we'll basically evaluate how the new flight controller runs, if the thruster response to various pressure levels are different, and we'll basically make sure the electrosprays are good, and we'll make sure that the new CPRS that we have are good. And basically when we have these hot fire testing, we'll be able to know whether or not the propulsion system is ready to be placed on the lunar flashlight, or we need to hold off and develop it some more before we place it on the lunar flashlight. So as of right now, we're actually done with the propulsion system, and really we just need to put on the controller and get things running. So our future plans are to get the new controller system set up and make sure that it's operational and all the functionalities work. The second thing that we need to do is to actually do thrust pulse testing. And basically with the 100 millinewton blowdown thruster, we will basically do thrust pulse testing, and we'll basically run it, and we'll basically label the pulse of the actual testing, so we know how it runs, and just if there's any sort of errors, that tells us if there's errors in the actual thrust. And then the third thing we need to do is various pressure runs. And for these pressure runs, basically we'll be using it to find really what's the minimum amount of pressure that we can run these thrusters at, and what's the max, And how does it react when we're in between those points? Is it stronger? Is it weaker? We need to do these pressure runs in order to know that information. And then lastly, we'll do the electrosprays. And for the electrosprays, we'll basically run through pressure runs too, but we have to do them each individually because we have 4 of them. We have to make sure that it fills up the tank correctly, and we have to make sure that our new CPRS system works well. And the new system is basically a new set of tubing within the actual CPRS, and it's very small. So yeah, thank you so much for listening, and I appreciate your time.